So given a list of items in a array, let us see how we can sort those elements in a specific order. It could be ascending or could be descending order. Right? So there are numerous algorithms available for sorting. Each of them have their own advantage and disadvantage. We'll look at some of the simplest algorithms available. So one of the algorithms is called a selection sort. Let us see how selection sort behaves. So let us say this is the array given to us, list of items, numbers which we want to sort. This is the position of the elements that is placed. Now in selection sort, what is done is every time you start looking for an element, you look for the minimum element in the list. Let us say I'm sorting this in ascending order. So in if I'm sorting in ascending order, the minimum number should come at the first position. That was zeroth index, right? So first we will look for the minimum number in this list and swap the minimum number with the first position. Right? So here you can say 2 is the minimum number. So we want 2 to come at the first position. So we'll swap 2 and 10. So first we'll search for the minimum number, do a pass through, compare each of these numbers with each other, find out which is the more minimum number in the list. So let us say we'll do something like we'll assume that the minimum number is at index 0. Okay, let me write here. We'll assume that minimum is at index 0. Right. Now we'll take the number in 0, 10, compare it with 2. 2 is smaller, so we'll change the minimum to index 1. Now compare the number 2 with number 4. It is 2 is already smaller, 2 with 22, 2 is smaller, 2 with 42, 2 is smaller, 2 with 30, 2 is smaller. So we'll finish the whole array, we'll find out the minimum number is at index 1, but this should be at index 0 because this is the minimum number. So we'll swap index 1 with index 0. So we'll put 2 here, we'll put 10 here, remaining elements will not change. Right, so that means in the first pass we have found out that we have got one minimum number available. Now we don't need to do anything with this. So next we'll start comparing from here, 10, 4, 22, 42 and 30. Alright, now again here we'll start with minimum to be at index 1. Sorry, compare index 1 with index 2. Index 2 is smaller, number 4 is smaller than 10, so update the minimum to index 2. 4 is compared to 22, 4 is compared to 30, 42, 4 is compared with 30. All three cases 4 is smallest, so minimum is this index 2. So next what we'll do, we'll swap 4 with, we want to put the index 2 element, which is the minimal number, at the index 1. So 4 will be put here, 2 is already placed here, 10 will be put in 10's fourth place, remaining 3 numbers stay as it is. So now these two are sorted. Again we'll start with 10. So now we'll say minimum is at index 2. Right. Now we'll compare 10 with 22. 10 is smaller, 10 with 42, 10 is smaller, 10 with 30, 30 is 10 is smaller, nothing to do. So it will remain as it is because 10 is already at its right position. No swap required. Compare 22, 42 and 30. We are starting with minimum at index 3. Compare 3 with index 3. 32, 22 with 42 is smaller, 22 with 30 is smaller, 22 is already smaller, so nothing to change. So these four are already at the correct positions. We were left with 42 and 30. So we'll start as minimum as index 4. 42 and 30 are compared. 30 is smaller, so we'll change index to 5. That is minimum index is 5. There are no more elements present, so this should come at index 4. So we'll place 30 here and 42 goes to the last. And we need not do any further comparisons because if the first n minus 1 digits are already sorted, the nth digit will anyway be sorted. So if you sort these many numbers, this automatically will get sorted. So you can see we have the elements in the sorted array. right? So you can see the insertion selection sort basically searches for the minimum number, selects the minimum number and puts it at its correct place in every pass, right? So let us see how we can put it into a program. Right, so we have a list of elements that we want to sort. We find out the length of list to find out how many times, because we want to repeat this. So there are 1, 2, 3, 4, 5, 6 numbers. We have repeated pass 1, pass 2, pass 3, pass 4. We have to repeat this loop comparison 5 times. Fine. So length is taken. We have to repeat it 5 times. So we while I is less than length minus 1. Okay, so to make it a little more easier to understand, let me put it like this. Y is I is less than length minus 1. So because we want to repeat it n minus length minus 1 times. I is the counter of how many times we have repeated it. Each time we're starting with the minimum at some index. So initially we're starting I is at 0, assuming 0th index is the minimum number. We start another for loop inside here where we are starting from I, whichever is the initial. For example, here I is 0, here I is 1, because we will keep shifting the beginning of our iteration each time we finish one pass, right? So first time we're starting with I as 0, 0 till length. We'll go through all the numbers, compare the number with the minimum number, right? So if this number is less than the minimum number, for example, here 2 and 10 are compared. If 2 is less than 10, then we change the minimum index to the new index, right? So assumption was, for example, start with 10 and 2. 10 is assumption is the minimum index. We're comparing 10 and 2. 2 is smaller, so index was changed to index 1. So we're changing the index value to index 1 here, right? If this is not the case, then nothing to change. Index will remain at whatever it is. So once I loop it through all the elements here, when we come out of it, if the assumption was wrong, if the minimum element was not the ith element, we can compare. If I is not equal to minimum, that means our assumption was wrong and we need to swap the elements. So in the list, swap ith element with the minimum element. So for example, here we're swapping 2 and 10. So in we are passing the list, we are passing the index 0 and index 1. So in the swap, it's a simple swap function. It takes the list, takes the two index values, and does a basic swap of two elements. Right? And because we are passing the full list as it is, the swap will be available. Whatever swap you do will be visible to us in this function also. Alright. So and we increment I by 1 to indicate that we have done one iteration, and again start with the next minimum value here. So and this keeps repeating. Alright, so we can instead of I can start with I plus 1 here, because that element is anyway considered. So let us test it here. X is equal to, this is the list we have taken. We are calling selection sort on X, and after the sorting we are printing the value of X. So let us see after the loop does the clear sorted value come or not. So I'll just run the code. You can see the output 2, 4, 10, 20, 30, 55. This is the expected sorted values for this list in ascending order, right? So that's how selection sort works. The complexity of selection sort is n square, because at in the worst case scenario we'll be looping through all the elements. There are two loops here, right? And if you swap every time, then if there are n into n times we'll run the loop, right? So uh, the complete derivation is not required right now, but the worst case time is proportional to n square. So the running time or the complexity of the algorithm increases at as a square of the number of elements increase, right? So that's about selection sort. Thank you.